Okay, so first of all, super pumped to be here. It's like a dream come true. My talk is called The Curious Case of Swift Testing, and we're going to get into it because I'm going to be pretty extra about it. That's kind of a thing about me. I'm extra. A little bit about me real quick. I've worked at a couple places. I worked at Apple on the accessibility team. I worked at Marvel. Captain America was never in the office. He was always out doing other things. I have my own little indie app studio called Aberfeldy Studios, where I make an app called PediaPal, but more on that later. And some of the events that I help with iOS Dev Happy Hour as one of the organizers, and I helped create an event called Community Kit, which is something that we do for connecting the community worldwide. I also helped work on a project here in Melbourne when I was in the States remotely, a little iOS game called Gesundheit. I remastered it for iOS, visionOS, and all the other platforms except for the watch. But the best work that I've done is with my family. I have a younger daughter, a younger son, and a newborn baby, and my wife, Mary. And they're pretty great. And it's great that I'm able to be out here because Mary is holding down the fort. But now, let's talk a little bit about Swift testing. And I'm going to give it kind of a noir vibe because when I started testing for my app PediaPal, I felt like I was a detective. And I thought, why not just run with it the entire time? So for better or worse, we're going to be detectives today. And you may be thinking, this is that kind of talk about unit testing where it's like, you should be doing this, you should be doing that. I can't give you that advice because I didn't have that mindset. I only reached for Swift testing because I was panicking, I was in the middle of a problem, and I couldn't tell what was going on because it was something that had millions and, well, thousands of data sets, and I couldn't possibly test them all individually one by one. Otherwise, I'd still be at home right now on maybe number 1,000. But anyways, let's get started. The brief was simple. Make the numbers behave. And I've heard that before. Behind simple, there's always a twist. And so the case so far I wanted to compute for my app PediaPal pediatric growth percentiles easily. And that word easily is a bit of a pain point now. The constraints that I had were I had a bunch of massive data sets, mixed ages, multiple measurements, you name it. And it would be considered correct if the matches were within the medical reference and I had next to no error, because if I had massive errors, my app would be laughed off the App Store in its very short lifetime. Now they say the old chief XC test is reliable, sure, but this case needs a rookie who talks, one who tells you exactly where the crime's going to happen before it happens. And so I went with Swift testing. It was descriptive and organized, and everything that it said to me made sense. I could read it like I could a book. XC test I'm a little bit frightened of, so I can't really sing its praises because I'm a bit of a coward in that regard. But one of the things I like about Swift testing is its actionable failures. It tells you anytime you run your test, it does the observed and expected. And I mean, that's not anything new for test suites, but I feel like for reasons I'll get into later, it does a really good job at that. And it's also super scalable. I could run tens of thousands of test cases. And so when my friend Matt Heaney told me about Swift testing as a means to do all these pediatric percentiles, which there were tens of thousands, and its high volume ability, I was like, great, that sounds like exactly what I need, because I have no clue what's going on. My sister-in-law presented the feature and she made it sound really easy. She was like, it's just a quick thing you throw in there. And I said, great, I'll do it. It took me 3 months. I don't know if that's quick for anyone, but that's not quick for me. But what I needed was something that could reveal patterns, show me some error zones, and something that wouldn't make me have to refactor a lot, because I really didn't want to do that. But spoiler alert, I ended up refactoring a lot. So the badge, the notebook, the magnifying glass. In my world, that's the target, the input, and the macros. And so adding Swift testing to your project is just as easy as, file, new, target, unit testing bundle. And this is a quick sample snippet that just kind of shows you how easy it is to add it. You import testing because we import everything. And this testable annotation is really nice because it lets you import your module. So in my case, mine was import PDFL, but for the sake of this talk, I say growth math because we're talking about percentiles. And you can see I have these test annotations and such, and we'll get into how that works. So these two macros, expect and require, give us the nuts and bolts of testing. The real difference between the two is that expect will keep on running if it fails, and require will stop immediately. And require is really great for ensuring optionality, and that's how I use it 99.9% of the times. In any of the talks from previous dub-dubs, you'll see that's what they say too. Now, because of any number of factors, it's not practical to allow these values to be exact matches only, especially when they use up around 10 to 16 decimal points of precision. So at first I started rolling with 3% error. This is not something that Swift testing immediately gave me, though, and I want to reiterate that. Swift testing doesn't automatically give you this tolerance, at least not yet. Maybe someone will add it in the future. I had to import something called the numerics package to get this tolerance checking, and it involved a lot of deep dives on Reddit and sadness. So I dusted the scene, prints everywhere. But this time, thanks to Swift testing, the prints had names, addresses, forwarding numbers, family members, motives, and alibis. The failures captured the source, again, that expected versus actual results, and it showed me exactly where things were going wrong. And my first run had hundreds, if not thousands, of failed tests, which you may think is bad, but for me, I was happy to see because it was exposing an area where I needed to do the work. So this was an early clue that my math, surprise, surprise, was not great. So I adjusted the math with precision so tests catch the bugs that once hid. I've tagged all the traits and the cases to shine light on sneaky dark places. Now parameterized runs broaden what we did, then the suites hold the chaos. Each sandbox is spacious, and the irrelevant runs, they're gone, so audacious. We scale to 10,000, a flood of new patterns. The nets keep on catching our confidence fat, and success isn't vague, it's exact, it's resilient. Pass with intolerance, no median bias, and every result reproducible, brilliant. So I ran the data through the grinder, and the city lit up red. Everywhere I looked, something was broken. It wasn't a bug, it was a crime scene. Swift testing decided it was time to kick it into gear. So yeah, tens of thousands of records were all mismatched, and like I said, failures everywhere. A lot of the graphs that I had diverged, and the numbers were just all over the place. There was clearly, like I said, something wrong with my math. And so this is when I really decided to put Swift testing to use. And before I get into how I did that, we're going to talk a little bit of shop about the things that Swift testing does. So you don't solve a case with memory. You take notes, tags, traits. They're the sticky notes on the corkboard, where reminders of where the culprits have visited. And so the traits are really nice because they add a bunch of descriptive info to your tests. You can add these tags, and so I split things with pediatric and infancy, and so I would make infant tags and pediatric tags so that way I could keep track of things in my tests. And I could control whether these were run with enabled and disabled flags. And these are great for times when you're ready to run certain tests but not ready to do other ones. So I have BMI buried in PDFL. I'm not ready to open this lid again. But those are all disabled right now. And so when I'm ready to add them, all I have to do is just flip them to enabled. And it's really nice. You don't get all the red X's for your not ready tests. And therefore, you don't have to take the beating on your confidence. And this is really great because you can mark all of your failing test cases specifically, and you can build a searchable evidence log. Now, I'm going to say this probably at least a dozen more times. The actionable failures of Swift testing is really nice. Other tools just shout fail in your face. Swift testing whispers, here's what you asked, here's what you got, and here's where it all went wrong. That's the kind of snitch you need. So it captures the source expression when it runs everything. It shows, again, the expected versus actual result inline after running. And again, that sounds like normal testing behavior, but you'll see later why that's really awesome at high volume. It's fantastic for really, really big data sets because you can use it to quickly locate the mismatches that you're dealing with. Now, the failures are the clues, and they're not dead ends. And honestly, that's a nice piece of life advice, because sometimes we just sit there beating our heads on the desk feeling like failures, but it's just the next step. Maybe I'm doing a little bit of self-life coaching, maybe not. Now, every lineup's got a troublemaker. For me, it was the kid in the middle, the 50th percentile. It looked innocent in the shadows, but under the lamp, cracks everywhere. So a lot of failures were clustered around the median of the data. The outliers and the edge cases were fine and worked well. All my tests were passing. But as I got closer to the 50th, from either direction, the failed tests ramped up in number. And all of the ones at 50 were wrong, even though they should have been 0, So after fixing the math, thanks to the other things that testing exposed, I realized that maybe my model assumption isn't that great. So I got into making more organized tests. And of course, any good detective tell you, you don't toss all of your evidence into a single box. You file it. Suites gave me cabinets, folders, neat little compartments for every little subject. And so that's how we group our tests together. And each suite has its own life cycle, an init that runs before each test and a d'init that runs afterwards. And it's really nice because it isolates the states of each of the things that you're testing. So you're not cross-contaminating or having any old artifacts. You know for a fact that what you're testing is not being affected by old tests. So that's a little bit of cognitive overhead off of you. And it's really nice because you can also nest suites within suites. And so what I ended up doing is for my suites, I would do, okay, suite, CDC tests, pediatric, height. And it would be really nice because you can also run those specific suites instead of doing the whole thing at once and waiting like 20 minutes for like 100 tests. So I don't let the suspects talk in the holding cell. One in, one out. No whispers, no collusion. Suites, keep them honest. Now, each test starts with a clean slate, like I mentioned, and it avoids this shared mutable state. I don't know if any of you know who James Dempsey is, but he has a really nice like barbershop quartet, My Beautiful Mutable Shared State. When I was writing this, I could not get it out of my head. All of his songs are earworms. So if you're ever around for Dub Dub and get a chance to go to his concerts, I highly recommend it. The dude's a genius. But one thing that Swift testing does more so than XC test is it encourages the value semantics since we're dealing with structs. And it's reliable, and again, it gives us reproducible runs, which is what we're after, without the fear of, am I doing this correctly or not? So one nice thing that we have is the ability to enforce some runtime conditions on our tests, so that way we can get some even deeper granularity. So we can skip the irrelevant cases with the enabled tag, but we can also pass it a conditional if argument, which is basically something we can use to hinge whether or not these tests run. Like, so for instance, in the example I have provided, I could do it by age, so that way I could target specific age groups, because the percentile graphs bend around, okay? And so it would be really nice to be able to focus on a subsection of things, so that way I could really get into it and maximize my time. Minimize my time. I don't want to maximize my time. And this is one of my favorite things about Swift testing is, if you're working with bugs and you're working on tickets, you can annotate your tests with this bug tag. And I have a number in there. You can put a string or whatever you want. But it's really nice because you can run all the ones based on the bug that you're dealing with. You can get in and get out, and it's a lot faster. I skipped this one. You can mark your test as disabled and flag a reason for it, which is really nice for people coming in behind you and doing the work. Now, if any of you are working on taking your app from iOS 18 to iOS 26, you probably are so sick of the available syntax that I know I am, because I've been doing it for the past 3 months and I'm ready to throw it out the window. It's really nice because Swift testing makes it so easy to avoid stuff like that. So the tags and subsuites are the colored string on the conspiracy board. We tag the infant cases red and the toddler cases blue. And suddenly the chaos has shapes. Okay, I didn't really use colors, but it felt like I wanted to create the metaphor of the wild conspiracy board. All right, so let me have it. So we can tag these things across all of our files and suites. It doesn't have to be just inside of one nested item. And you can filter by your tags in the test navigator, which is really nice because, again, finding things quickly seems to be something that Swift testing really cares a lot about, which I'm happy about. And again, that hierarchy is really nice because you can use it to isolate things and run specific things and even go broader or deeper as you see fit. So by now, I had a desk full of notes, cabinets full of files, and a board covered in string. The case wasn't solved, but I finally knew where to look. And so we had these really nice tools that are worth recapping because my goal is by the time I'm done with this talk, you'll say, hey, maybe Swift testing is actually kind of cool and I could do it. If not, that's okay. That's how I was until Matt kind of made me do it. I was kind of forced against my will, just like you are right now. So again, we have traits, which gives us metadata that it lets us tag our tests and make them say things that are meaningful to us. The compiler doesn't really care what you call your tests. Suites are really nice because they give us a sense of organization and hierarchy, which as iOS developers, or mostly iOS developers, we all know that hierarchy is important. And we can skip irrelevant runs with things like runtime, checking, and conditionals, which makes our life easier. And then we can use our tags to also group additionally to our suites. Now this next part is the best part of Swift testing. It is if you're going to walk away with anything of why you should use Swift testing, what I'm about to say is the big cheese. So instead of grilling suspects one at a time, I lined them up under a single lamp and asked them the same question and watched who sweats. And then in Swift testing, we do this with something called parameterized testing. So you write one test and you feed it as many arguments as you want. Now, if you've ever been with XC tests, again, something that I'm afraid of. If you like XC tests, I'm sorry I'm dogging on it. I'm sure it's like fantastic for this. But you have to write each individual little test case and you get like tens of thousands of lines of code in that file. Whereas with Swift testing, you can condense that all into pretty much one function. Because you can pass in, you can use these arguments that it has here in the test annotation to have it pass all of those into your method, your test method, and test all of them. And not only does it test all of them, but it tests all of them in different orders each time. It really does a good, thorough job. It does things that you really don't want to do. You just want to say, is this correct or not on a grand scale? And Swift testing says, yeah, let me look. And so and the nice thing is, so this is why I was harping on the correctness, the observed and expected stuff, because when you run parameterized testing for something like tens of thousands of sets of data, it will flag which ones are messed up and it won't bother you with the ones that are correct. So it'll say oh, the kids who are 3 and who are just exceptionally tall, it failed for 5 of them. There was one that I was running where it would fail on 514 specifically. And the good news is eventually I solved it. At the time I was kind of like, what am I supposed to do with this? But the nice thing about parameterized testing is you can use it as small or as large as you like. It's super, super, super scalable. It is the power feature, the Corvette. No, we could do better. That's the Ferrari of Swift testing. Okay. If you get any takeaway that you get from Swift testing today needs to be that parameterized testing is kind of the boss. Okay. It is just awesome. So a good detective doesn't waste time repeating himself. One question, but many answers. The guilty ones, they always twitch. So this matters, this parameterized testing stuff matters because under the hood, if you have 2 tests that are the same, it will detect that and it will run just one. So it basically filters out all the extra stuff. And you may be wondering, oh, I added this on purpose. Why are you filtering this out? It does some super duper Swift compiling, trademark, copyright, magic stuff under the hood that does it how you want it. And of course, you can always specify to include things if you want to. But it makes your failures clearer, which is a big deal because a lot of us, raise your hand if you've ever been victimized by the Swift UI error where it says the type expression could not be determined and it's super vague. I know more of you have been affected by this, okay? It's not just 10 of us. The nice thing is your failures, when they fail, you get a really nice set of logs about them and it kind of shows you what you passed in, where you are, and you can always use the debugger too, but the logs are actually useful. And of course, with parameterized testing, you just add to your list of arguments as you decide to do more and more things, which is really nice. You don't have to reconstruct your tests. I don't know if you've picked up on this. I don't like redoing a lot of work. And so because of this, I got to test hundreds of thousands of age and sex combinations in this way. And I got to do it for the World Health Organization and CDC stats, which was just enormously helpful. So again, the benefits of parameterized tests. It's a lineup that gave me leverage. It's less paperwork, more insight, and the beauty, you can just re-interview the guilty ones that you find. So again, you don't have to copy and paste as many tests as you would have had to do with XC-test, which is fantastic. I love that, more readable. Adding more coverage is pretty trivial, honestly. You just add extra arguments. You don't have to conform your tests anymore. And the granularity to show which arguments fail is just super awesome. And the level of detail it shows which it fails is also really nice, because it gives you something you can go back and do, and you can say, okay, this is failing on this point. I know how this works. I wrote this code. I hope you wrote the code. And I can do something actionable about it. And then the actionability that it puts in your hands is just amazing. But one thing that's really awesome is that because Swift testing was created in the age of Swift concurrency, that glorious black box that only 10 of us on the planet truly grasp, is that it runs all your arguments in parallel. It runs your tests super, super, super fast and super, super, super performant, which means that not gone, but limited is the paradigm of running your tests and going to get a coffee and basically running off to lunch and getting back before everything's done. It runs really fast. But of course, sometimes you don't want that behavior, and so you can flag it to run serialized, which I included an example of here. The default behavior is the parallelization. But sometimes you want to run things serially because the order matters. For some of my tests, the order mattered for how I was assembling things. All right, so I thought I had my break. I did all this stuff with my testing. Most of the city was cleaned up, but the 50th percentile kept grinning at me, that punk. And so I made my calculation different. I was good at math now by my teacher's standards. My patterns were clearer thanks to the tests that I were running. I thought I had it all figured out. I thought I aced it. I thought this was it. I thought it was archive, test flight, ship. But no. The 50th percentile was still laughing at me. It was laughing up at me from hell. And it was a signal, of course, that something was going wrong. And so me, being a rational human being, did what any human being would do. I went undercover and I learned R. I learned the language of the streets, of the doctors. In this case, the streets spoke R, so I learned R. Was it a great time? No comment. But a lot of the percentile charts for pediatrics were made using R. A lot of doctors use them. It was less of a black box at the end than it was when I started. Do I remember any of the R? No. Do you know any R? So I basically learned enough to read a lot of the scripts that they wrote and to see how they were doing their stuff. And I found a lot of information on how they were writing their approximations. There were some in the numerics package for interpolation that were pretty close, but I basically kind of one-to-one took the R approximation method and remade it in Swift, which is kind of a cool little nerd fact. But I used it to compare the reference for percentiles and related operations. And basically, over the course of one really, really, really long coffee visit, I feel really sorry for all the baristas who had to sit there and watch me just kind of, what's happening? I got the math reverse engineered, and so I felt solid about it. And it turns out the perp wasn't hiding. I was just lurking in the wrong spots. I was forcing a straight line on a crooked street. And the bad guys, the villain rogue, made me pay for it. So because of the data that I got from the CDC and the WHO, it was easy to assume a linear interpolation just because of the way the points were. But the R scripts had so much more involved. And so it turned out that these charts were using cubic splines, which if I actually would have spent 5 minutes looking at the actual graph, I could have been like, oh yeah, that's not a straight line, Mom. So the result, of course, were the outliers would match fine because I could get them to match the beginning and the end. But as that line went forward, the graph dipped out. And so that explained why my results were diverging more. So it was a model mismatch, not a coding bug. Never mind the math that I had wrong before. So it turns out the third time was the charm. The numbers sang, the graphs danced, yay, and the case file was slammed shut with a thud. I implemented the cubic approach. Wasn't terribly difficult. I had to maybe think back to 5 minutes of my high school algebra. The errors all suddenly and magically went back into that not only 3% tolerance, but it went less than 1%, which I was trying to make my linear approach really hammer into under 3%, and I was getting super frustrated with it. But it turns out when you use the right model, everything kind of works. And so all of the large data set tests that I passed, tens of thousands, passed correctly, and that was awesome. I had assurance that things were working. Now, Swift testing didn't hand me the answer. It gave me the flashlight, and once I lit up the alley, the truth was waiting for me. It was awesome. And again, I'm going to reiterate, I'm not that guy who says, you should always do unit testing at the beginning of every project. I have notorious ADHD, folks. I cannot offer you organized advice. If I do, that's extremely hypocritical, and if you catch me doing it, I need you to give me kind of a look. But I use it as kind of a bailout tool, which is kind of a neat use case for it. It really shone on the issues I was having, and it cast a bunch of shadows that I was able to kind of extrapolate. And it showed me, because I was able to see where things were on a grand scale, I knew where to look rather than floundering around hoping for the best. I'm gonna be very honest. I put this into ChatGPT in the early days, and I was like, what's wrong with my code? I was like, ChatGPT, save me. ChatGPT made it worse for 2 days. So you cannot, it's good for things, and I've learned over the past year that I'm going to use ChatGPT on things that I kind of know and boilerplate things, because if I give it something that I don't know, there's a good chance that we both don't know, or we're just kind of going to look at each other and go. But so without testing like this, I would still be guessing, and it would be a miserable time for everyone, especially in my house. Although something cool did come of it. I wrote a bunch of cool math and symbols on the board, and my wife and my father-in-law came inside one day and they're like, wow, Adrian's so smart. And I was like, never mind the Wikipedia article that I just ripped that off of. And I was like, if you want to impress somebody, write a bunch of Greek gobbledygook on a board. Literally, people will think you're like a rocket scientist. It is the coolest feeling. I think my child went to school one of the days I was working on it. I was like, yeah, my dad's an advanced astrophysicist. And I think she heard that movie because we've been watching the Marvel movies. And so I think she heard the Tony Stark, when did you become an expert in astrophysics? Oh, overnight. And so kind of a cool coincidence. I didn't correct her yet. No, I did. All right, so sometimes you work both sides of town. The veteran handles the street work, and the rookie handles the clean cases. And so there are ways you can migrate from XZ test to Swift testing if you're interested. But both, again, are very useful. And in this kind of harkens to the Swift UI, UI kit debate. They're both useful, and they can be used. The one's not just overtly better than the other. We don't have to have that argument every 5 minutes, folks. But to graduate, words are hard. To migrate, you want to do so gradually, just with anything. Just, for instance, things like Swift data for core data to Swift data, from UI kit to Swift UI. You want to do it slowly and measurably, okay? Horror stories, folks, if you try to do it all at once. So the nice thing is, a lot of the XZ tests that you probably have written are a lot of really, really, really long sets of tests that get coverage for a single problem. And so we can use the parameterized testing of Swift testing to solve that problem. So you can get the nuts and bolts in your method in Swift testing, and then take all of your other tests and make them work as parameters. If you haven't used tuples before, folks, if you use Swift testing and parameterized testing, you're going to become best friends with tuples. They're the best way to pass in arguments right now. There's a couple flakes with them, but tuples are kind of the accepted way right now. I'm sure there are going to be more convenient ways later on. And so the nice thing is, in doing it this way, you reduce a lot of the XZ test boilerplate. And so you'll get this kind of satisfaction of watching your test files shrink and get all the same amount of work done. Now, there are some things you still need XE tests for. For instance, UI testing. Swift testing does not get anywhere near that, folks. And quite frankly, neither do I. I'm kidding. My friend Matt, who told me about Swift testing, told me about this really cool pattern called the robot pattern. I hope he gives a talk at a conference at some point in the world. It was so awesome. It made UI testing so accessible, but that's not what we're here for. And then performance testing, you still can't use Swift testing for. So this rookie, he's not locked up at HQ. He's out there on the streets, open for anyone to train, shape, or sharpen. Swift testing is open source, like a lot of other Apple technology out there. And it's actively evolving with community feedback, which is why I was kind of like, maybe one day it'll have this, maybe one day it'll have that. If that's the future you want, you can contribute and be part of it. Contributions are welcome. You can offer bug fixes, you can suggest features, and you can add more of the docs. Docs are always great. We need the app intents teams to have more docs too. That is neither here nor there. That's just a gripe that I have. But so this means that your detective toolkit is only going to get better over time, and Swift testing is only going to continue to grow as long as people are interested in it. So every dead end was a clue in disguise. Swift testing didn't solve the case for me. It just showed me where to dig, and it can show you where to dig too. So the failures are evidence, not defeat. The test revealed the things that were wrong, the patterns that we had, and it showed me how to start the hike for correctness. And so testing is not just a method of ensuring correctness. It is a process of shining a light on where you need to look to fix things efficiently. It is such a good tool to have in your belt. Now I am that annoying evangelism guy on testing. Like, that's kind of like my personality, at least this week it is. But even hard problems, whether it's your code messing up or some kind of typo you might have put, or using the wrong interpolation method for graphs, it becomes solvable when you have the right tools. And that's true for anything. It's not just testing. So percentiles, cubic statistics, oh my, I never asked for this case, but Swift testing gave me the light to close it. So my percentiles are now in PediaPal. They work well. I'm quite confident in their correctness. And Swift testing was a really good partner on this, and I've been using it since to do other work. So this is what the app looked like when I made it versus June. This is PediaPal, and it looks a bit rough. You can see when I tried to build it for Liquid Glass, you can see that plus button, my little gambit was exposed. If you think it looks bad, it's okay, it does. It looks quite bad. But I'm happy to say that on the day iOS 26 drops, PediaPal is going to get a new look. And so I need more folks from Australia to use PediaPal because I have plenty of folks from the UK and the US using it, but I want to make it more, I want to make it better around the world. So if you scan that QR code and sign up for the mailing list today, because I was having trouble with App Store Connect this morning, I will personally make sure that you get a very long trial. I'm thinking probably a year to try the app out. It's ideal if you have small children. So if you have like kids at uni or you have babies. I mean, babies are good too, but kids, it's basically kind of the pre-health kit solution for children before they have their own device. And you take care of it. And so yeah, thank you for listening to me ramble about Swift testing and going off the rails and living out my detective fantasies. If you want to find me on social media, that QR code will get you there. I'm Swifteves on everything, so you can know to follow me or to block me. But anyways, I wanted to say thank you very much for having me this year. This is such a cool event, and I really am looking forward to meeting a lot of you just in conversations and events. Oh, and real quick, so I run a thing called Community Kit. It happens every year. We do small events over the course of the year, mostly online, but every year at DubDub, we do a thing where we host our own kind of parallel unconference. I say every year, we did it one year, and we're coming back for a second year. But it's really awesome, and if you find yourself out there, or even if you find yourself wanting to go and you don't have a ticket, you should come, because we have a lot of really great things stacked up, and it's really worth coming, and we would love to have you there. One of my favorite events that we do is called the Indie Fair, which is if you've made an app, you can request to have a seat at a booth, and basically it's like a science fair, except you're showing off your apps. And this year we had just crazy amounts of success with it. For 2 hours, the hotel room was just completely full with people coming in and out, handing out stickers, meeting each other. It was just a really good time. And community is at the heart of iOS development, whether you want to realize it or not. And it's just extremely important to me. And I just hope that whether it's an in-person conversation with me or something like Community Kit, that I hope I make you feel welcome. And so thank you for welcoming me. I hope I can return the favor to others.